Hello. This will be the third and last lecture for chapter 13. We are still working on colligative properties, which are solution properties, in particular the boiling point and freezing point, which are affected by the solute of solutions. Last time we calculated the effect of 0.87 grams of magnesium sulfate in 15 milliliters of water. We use this formula to calculate the change in boiling temperature, and the only thing we're going to change now is calculate the freezing point, and so for that we need a different constant. This is the constant for boiling point elevation. The degrees that the boiling temperature goes up by is 0.512 grams, 1.512 degrees per mole. For freezing point, that is 1.86 degrees per mole. So all you have to do is everything stays the same, the number of moles, the Van Hoff factor, and the solvent, and the molarity, of course. So the only thing that changes is 1.86, and so we end up with a change in freezing point of 1.79 degrees. We subtract that from the normal freezing point and end up with a freezing point that's negative 1.79 degrees Celsius. Okay, so let's move on to a different solution. And I have kept the mass the same and the amount of solvent the same. But so we still, everything here in black has not changed. But of course we have a different substance. We check the Van Hoff factor. It changes. Magnesium chloride produces 3 ions in solution. Magnesium ions and 2 chloride ions, so that's a total of 3 particles. So our Van Hoff factor now is 3. The solvent remains the same, but the molarity, the molality also changes because the molar mass is different. So the molar mass of magnesium chloride is 95.2 grams per mole, and so if you apply that, you get a molarity, the number of moles of 0.00914, and the molality then is 1.83. We keep the boiling point elevation constant since it's still water, and we have an increase in 0.936 degrees, which is 101 roughly. Okay. Here's a different problem. This time we have antifreeze, and I give you a formula, C2H6. And so you need to figure out if this breaks apart into particles or if it stays together. It is a non-electrolyte, it's polar covalent, and I will not tell you that. You will have to determine that. If you look at the formula, it's just nonmetals, carbon, hydrogen, and oxygen. So you should know that's simply a polar covalent compound. So our number of particles is going to be 1. We still use the same freezing point constant. I'll have that on the next slide. But of course, when we calculate the molality, first we calculate the number of moles from 200 grams of antifreeze, divide by the molar mass, C2H6O2 here provided. That's where the 62 comes from. That gives us 3.2 moles. Van Hoff factor is 1. Of course, 200 grams of antifreeze are 200 grams of actually I'm talking about water now, right? Our solvent, 200 milliliters of water with a density of 1 gram per milliliter turns into 200 grams of water. And convert to kilograms, that's 0.200 kilograms. We end up with a pretty high molality, so this will have an effect much larger than what we've seen before on the boiling point and freezing point. I'm only asking for freezing point here. So it is 1.86 is the constant, the molality is 16, so end up with a change in temperature of 30 degrees. So the new freezing point of this particular solution is 30 degrees, negative 30. And of course antifreeze is used in radiators, so in the winter your car will start and the the antifreeze, the solution that cools your engine, is not frozen, and that's important. And it also, you can calculate the change in boiling point. You'll find it's also much higher than 100 degrees, which is also important considering that the engine of a car gets much higher. Looking at another solution, another aqueous solution, again water, and then the final slide will be a solution that's not in water, but we have a glucose solution now, 55.8 grams of glucose. That's the mass of the solute. I'm giving that's added to 455 grams of water. That's our solvent. We can easily calculate how many kilograms that it is, and so we ask ourselves about the Van Hoff factor. We already know that glucose is a polar covalent compound. Again, we just have carbon, hydrogen, oxygen. It is not an electrolyte. Glucose is sugar, does not conduct electricity. So we have one particle. That makes our molality much easier. So let's calculate molality. First, we need the number of moles. We get that from 55.8 grams of glucose times 1 mole of glucose. It's roughly 180 grams per mole. That gives me a molarity, or number of moles, that is 0.3097 moles. What is the mass of the solvent? Is 455 grams, so that's 0.455 kilograms. So the molality is going to be 0.3097 moles divided by 0.455 kilograms, and that gives us a molality of 0.681 little m, and then the change in, and we are determining the freezing point and the boiling point. So we have two calculations. Delta T freezing point, first of all, is going to be 1.86 molal per, that is of course degrees per molal, times 0.681. See, our units cancel here, and we want our units to be in degrees Celsius, so that wasn't going to work. So for the freezing point, we end up with 1.27 degrees. Subtract that from the freezing point. Our new freezing point is negative 1.27 degrees Celsius. Similar calculation for the change in boiling point. The constant is 0.512 degrees per molal. The molality does not change, 0.681. Molality changes. Our answer is in degrees. That's 0.349 degrees. And so the new boiling point is going to be 100.349 degrees C. Alright, moving on to the final problem, and then it's time for you to do some of those on your own. This time, as I threatened, we have a solution that is not in water. Here we have 7.55 grams of ethylene glycol. We already worked with ethylene glycol. That was the antifreeze. And we added that to 85.7 milliliters of ethanol. So our first calculation is to determine the molality of this particular solution. Our solute is 7.55 grams of C2H6O2, and it's roughly 62 grams. You can do better than that. You should have three significant figures. So let me just look that up. It's 62.07 grams. That gives me the number of moles, 0.122 moles. Of course, ethanol has a much lower density than water, so I have to apply that to the milliliters. I can't just use 85.7 milliliters. Oh, it's 85.7 grams. That's not true. We have 85.7 milliliters, and we apply the density to that, 0.789 grams per cubic centimeter. Cubic centimeter is the same thing as a liter, so a milliliter, so works out perfectly. We can just replace cubic centimeters with milliliter so that our units cancel. That is our solvent. Our solvent needs to be in kilograms because molality, which is what we want, is in kilograms of solvent. We do have the 0.122 moles, so we also have to convert that to kilograms, since there's 1,000 grams in a kilogram. Grams cancels, milligram cancels, and so this gives me a mass of 0.0857 kilograms, which we plug into here. And this gives me a molality of 1.80 little m. Great, so all we have to do now is calculate the change in temperature of the freezing point. I am giving the constant here 1.99 degrees per molal. So we have 1.99 degrees per molal. We multiply that by 1.80. Molality cancels, and we end up with a change in temperature that's 3.58 degrees Celsius. That's the freezing point. We're provided with the freezing point negative 114, so we subtract that, negative 114.1 minus 3.58 is going to give us a new freezing point that's negative 117.7 degrees Celsius. New freezing point of the solution. Boiling point, very similar. The factor is 1.22 degrees C, or degrees per molal, times the same molality, and that's slightly lower. It is 2.19 degrees. That's how much it goes up by. We are also given the boiling point of ethanol, of pure ethanol. We add that to it, so 78.3 plus 2.19 gives us, gives us a new boiling point of 79.5 degrees Celsius. Alright, so I suggest you go to active and work some of those problems. I got plenty in the practice section, but I also have quite a few for homework. There's some in the back of the book, and if you want more, give me a call, come to my office hours, ask me for more, and I'll provide you with more. Alright, see you in chapter 14.